Okay, so today we're going to extend on our topics from yesterday. Math is very sequential. Right? That's why I really like the analogy of the bricks tower. Last day, we wanted to work specifically on your basic adding, multiplying, dividing skills. Because today when we work on something called factors, you have to have some pretty solid, well, I mean, that's what we're going to do. We're really going to focus on your multiplying and your dividing. For any of you who already started working on the assignment questions, if I ask you for something like the factors of the number 6, it really helps if you have in your head already, you know that 2 times 3 is 6. Or 1 times 6 is 6. Right? If you are constantly going to a calculator trying to find what times is to give 7 or 19, that's going to be hard, right? How in the world are you going to find the factors of 3,294? Because we're going to start little, right? And it'll get harder and harder. So today's topic is factors, which I think you guys already know this word a little bit, right? A factor is essentially part of a product. I'm just going to highlight it. Factors are considered to be any values which are multiplied to create a product. So if you can multiply two numbers to get the number you're looking for, that's a factor. Usually use whole numbers. So like I already have this example here. Factors of 6 are 1, 2, 3, and 6, because 1 times 6 equals 6. So these guys are factors. 2 times 3 equals 6. So again, all of these numbers here are factors. Why is 4 not a factor? Does 4 times 2 give 6? Yeah, sure, it totally does. But you got to times it by 1.5, right? So we don't usually consider decimal numbers. We also usually don't consider the integers. You guys remember what integers are from yesterday? Yeah, they can cross over into negative numbers. Yeah. So we're basically looking for nothing that's a decimal or a fraction or a negative number, but if it's a whole number that multiplies, then that's a factor. So again, hopefully that third layer of your table for multiplying and dividing, hopefully we're good at it. And if not, if you can't do 5 times 7, good. Right, if that didn't happen like that, we got to work on it. Right? Because it's going to slow you down if you use that calculator every time. So let's do some examples. What sort of numbers could times to give 7?
0.
Well, 0 doesn't times to give anything, actually. 1 and 7 will do, yeah. Because 1 times 7 will give 7. So therefore, 1 and 7 are both factors. Does 2 times to give 7? Yeah, the answer is no. But you know what? If you had to go to your calculator to figure that out, you're taking too long. Right? That's not going to work. Siri is 7 divided by 2. Siri is 7 divided by 3. That's not going to work, right? So we have to develop some solid skills where you recognize some rules. I already chatted with some of you about this. 7's an odd number. Even numbers will not go into odd numbers. Let's just do a couple of quick checks on that. Let's say I have 2 times 4. Those are even numbers, right? That's 8. It's also even. 6 times 10. Those are even numbers, right? 60. Also even. That'll be useful in a second. How do you get an odd number? The only way to get an odd number is odd times odd. Yeah. Because let's try some other ones. 3 times 4. Even times odd. That's 12. That's even. So if you want to get an odd number, we should only try odd numbers. So using some common sense here on this one for 7, even though some of you might know the answer's already done, should I bother trying to divide 7 by 2? Or 4 or 6? So it kind of cuts down the workload, right? Truthfully, the only numbers that go into 7 are 1 and 7. Let's try 20 then. What sort of numbers go into 20?
1.
Well, for sure 1 and 20, right? That's 20.
5.
2 will work, right? Now here's the cool thing about even numbers. If it's an even number, for sure the number 2 goes in. I guarantee it. So 2 will go in with 10. 3, well then, hopefully this is your process you go through, right? Does 3 go into 20?
No.
Hopefully you don't need a calculator for that. Right? You can just kind of think about it and go, no, 3 goes into 21. Not 20. 4 does. 4 goes by 5. I think I can stop. Because once you get to the point where like the numbers that you're finding, like the pair, when they're like right next to each other, there's no point in going any further. Because if I try the next number, 5, no, I've already got 5 on this list right here, right? So if I try 6 or 7 or 8 or 9 or 10, well, why try 10? 10's already sitting up there, right? So our factors are 1, 2, 4 and 5, 10 and 20. How many of you guys have done something like this before? Like this is not. Okay, right? This isn't a new skill, right? But in keeping the building our tower, right? I want to make sure that we start right at the very basics so that we build it nice and strong. Because eventually I'll ask you for more challenging numbers like say 60. There are a lot of factors to 60. So let's just walk through some logic. Right off the bat, we know 1 and 60 works, right? 60 is even. Guaranteed 2 goes in, right? So 2 times 30. Well, no, let's go up in order, right? So 3 works, because 3 and 20 will give you 60. How about 4?
4 and 15.
Yeah, that'll work. 4 and 15. Again, basic math facts really helps, right? Will 5 go in? What's the rule for 5s? If it ends in a 5 or 0, yeah, because multiples of 5 are either 10s versus 5s, right? So this should work. So hopefully you know your times tables. 5 times 12 will give you 60. 6 will work.
10.
Yep, 6 by 10. Okay, so now we get to the challenging ones. And I mean, if you need a calculator, at some point, sure, don't hesitate to grab your calculator at some point, right? But, you know, maybe you should be able to ask the question, is the 7 going to 60? No, it doesn't, right? Because I know that 7 times 8 is 56. 7 times 9 is 63. That doesn't work, so you're out. 8 times 8 is 64. That's too big. 8 times 7, 56. That's too little. That one's out. Right, we're kind of getting to the point now where the next number would have been 9 or 10. I already got a 10 right here. So I think I made my list. So the list is, we've got 1, 2, 3, 4, 5, 6. And then the partners that go with them are 10, 12, 20, 30, and 60. I kind of didn't draw that very nicely, did I? Did I miss
15.
15, thank you. 15's in there. Wait, I had someone ask me a while ago, how do I show my work? That's a good question though, right? Truthfully, for a question like this, there really isn't any work to show. Like, this is your work. Okay? But keep in mind, we're on like the 3rd level on the pyramid. Eventually, when we get higher, there will be work to show. Okay? So if you're kind of wondering, how do I show that 5 plus 3 is 8? You can just tell me that it's 8. Okay? So that's what I wrote here. When determining factors, sometimes you got to use trial and error. But don't forget to use good common sense. So already a couple of rules I can give you. If it ends in a 5 or a 0, it's divisible by 5. If it's an even number, it's divisible by 2. If it's an odd number, it's only divisible by odd numbers. It's the only way to make more odd numbers is to times odds by each other. Odd times odd is odd. Odd times even is even. Even times even is even. Say that again? Odd times odd will give you an odd number. Odd times even will give you even. And even times even will give you even. So if you're looking for the factors of an odd number, don't bother with 2, 4, 6, 8, 10. Here's another example. Let's say that 3 was not a factor of a number. Why should you not bother with 6 then? Yeah. I mean, another way of putting it is that 6 is made up of 2 by 3, right? So if 3 didn't work, how is something that is 3 by 2 going to work? 3 already wasn't going to work, right? So sometimes you can use some logic and say, okay, 4 didn't work, don't bother with 8. 9 didn't work, don't bother with 18. 2 didn't work, don't bother with 4 or 6 or 8 or 10. Have you guys heard these words before? Prime numbers and composite numbers? Hopefully that's a vocabulary words you've heard before. Prime numbers are basically, there's only 2 numbers that are the factors. 1 and whatever that number is. For example, number 7 here, this one's prime. Because what were the factors of 7? 1 and 7, yeah. 20 though is considered composite. Because it's made up of more than just 1 and itself. You guys heard those words before? Just a refresh on vocabulary. Here's something I should point out, by the way. The number 1 is not considered prime, by the way. It's kind of a weird anomaly. But the definition of prime is it has to be divisible by 1 and itself. But since the number 1 is itself, we kind of don't count the number 1 as prime. So prime numbers would be things like 2, 3, not 4 though. Why not 4? 2 and 2, yeah. 5 is prime. 6 isn't, because it's 2 by 3. 7 is prime. 8's not though, because of 2 by 4, or 4 by 2. 9, 3 by 3, that doesn't work. 10, 2 by 5. 11, 11's prime. Nothing else goes into 11. Anyways, you guys have used this term before? We'll move on then. So 60 is also composite then if we want to write that down, right? Because it's made of a lot of numbers. So one of the things that we try to do then is we try to find all of the prime factors. Essentially what we're trying to do is we're trying to boil any number down to like the basic building blocks of life. In a way, it's kind of like chemistry. Right? You're made out of matter, but if we tried to break it down smaller and smaller and smaller, what is matter made out of? Carbon, oxygen, nitrogen, helium, that stuff, right? Well, any number can be broken down in a similar way. The number 48 is really made of a whole bunch of 2's and a 3. In the same way, this table here is made of a whole bunch of carbons and some oxygens. Does that analogy make sense? So sometimes we just want to try to figure out what those factors are in the smallest forms possible. Some of you guys done factor trees before in like previous classes? Okay, so it's not brand new probably, but let's go through it. Basically the goal here is to break whatever the number is up into some factors. And if those factors are prime, we're done. If they're not prime, keep going. So like 48, for example, is 8 times 6. That works. Is 8 prime? No, it's not. 8 is 4 by 2. Oh, okay, well 2 is prime, so we're going to stop, see how it's in yellow. But 4 is not. 4 is 2 by 2. Okay, now we're done over here. Go back to this branch. 6. 6 is not prime, because it's 3 by 2. Okay, both of those were prime, we're done. So essentially, 48 is 1, 2, 3, 4 2's, and a 3. That makes sense. Does it matter what order you do it in? Not if you do it right. But this would be a good example of, okay, now we got some work to show, right? Oh, here's 108. I found this picture somewhere. 108 could be 6 and 18, and then 6 is 2 and 3, and 18 is 2 and 9, and 9 is 3 and 3. Oh, and so one person did their work this way, and that's fine. Oh, somebody else went with 54 and 2, or 36 and 3. But at the end of the day, 1, 2, 3 3's, 2 2's. 1, 2, 3 3's, 2 2's. So again, so long as you show me how you get your answer, that's fine. All right, so let's try one. Let's try to find all the prime factors of some of these numbers.
3 times.
Well, let's just start with things that multiply to get 15.
3 times 5.
Yeah, 3 times 5 will work, right? Can you break down a 3?
No.
Can you break down a 5? No. I noticed some of you maybe have been taught to circle it when it's prime. Is that something that like Bond or Quan maybe showed you? That's fine by me. Well, I mean, if you just want to end your answer here and say the factors are 3 and 5, that'll work. But we're not going to just stop with the easy ones, right? I mean, that's the whole point here, is that our goal is to grow and to stretch and to try to be creative in solving more challenging problems. So right off the bat, we're starting to hit some 3-digit numbers, 4-digit numbers. So 140. Anyone think of any factors of 140?
14 and 10.
That'll work. Yeah. I think there's probably 2 main strategies people do when they do this. They either look for numbers like Daniel suggested, where you look for some like middle of the road numbers like 14 and 10. Because then those ones will each break up into like say 5 and 2 and 7 and 2. That's a good strategy. I'd say some kids like to do that. Other kids try to pick out little factors, like one at a time. For example, when I look at the number 140, it's even, right? Even number means it has to be divisible by 2, right? So some kids would break it up into a 2, and then they'd work backwards and say, okay, 70. And then they'd say, oh yeah, 70. That ends in a 0. It's that's even, so I'll pick off another 2. You get your 35. And then, okay, well 35 is not even. So you gotta know your math facts. We're gonna need two odd numbers. 5 and 7. So some people like to just pick off like 2s one at a time. That's fine, I don't really care. But at the end of the day, we have two 2s, 5 and 7. So why don't we try this two ways again here? Let's try picking off just a small number to start with. Ends in a 0, it's even. Let's pick off a 2 then. 390 divided by 2. Okay, you know what, this would be a good time though? This would be a time where I think a calculator might be appropriate. Right? I wouldn't expect everybody to get that off the top of their heads, but yeah, 195. And then as I look at 195, the first thing that comes to mind for me is that, hey, that's a 5. That means there's a 5 in that number. But again, I don't think I'd expect you to have that off the top of your head, right? So is there a time and place for a calculator? Yeah, for sure. This will be the time. So someone help me out. 195 divided by 5? 39. It is, yeah. Yeah, this last one's a little challenging. It's 3 and 13. And 13 is actually prime. There's nothing else that goes into 13. So we're done. So that's one way of doing it, kind of picking off numbers little by little. Here's another strategy that might work. It ends in a 0. Anything that ends in a 0 is guaranteed to be divisible by 10. So you could have tried 39 by 10. Well, 10 is 5 by 2. 39 is 13 by 3. Again, it doesn't really matter. Here's good. Any questions? Okay. Well, the reason why we do some of this is that sometimes we want to do either what's called a greatest common factor or a lowest common multiple. And really the point of it is that we want to try to find commonalities between numbers, patterns that exist. Okay. So I think you guys have used these vocabulary before as well. Is that true? You guys have heard these terms?
Yeah.
So let's do a quick recap here. A greatest common factor is really just find all the factors and figure out which one is the biggest one between them. Lowest common multiple is where they are factors. So let's do the example here. Like 12 and 16. If I find the factors for 12, it would have been 3, 2, and 2. If I find the factors for 16, it's 2, 2, 2, and 2. Okay. Which one's very common? Well, there's a 3 on this guy right here, right? Does this guy have a 3? No. This one's got a 2. That one's got a 2. This one here has got a second 2. Does this one here have a second 2? Yeah, for sure. I think that's it. Okay, so apparently 2 groups of 2 are in common for both. 2 times 2 is 4. Factors are always smaller. Multiples, though, are bigger. If you struggle with remembering that, I just remember it because multiplying gives you bigger numbers. So multiple means multiply, bigger, right? So if you're looking for what's called the lowest common multiple, really what we do is we usually just write out like a pattern. Right? So if we're looking for 12 and 16 again, 12 times 2 is 24, then 36, 48, 60, 72, right? I'm just adding 12 every time.
Chris,
You need me.
I need Chris just for about
Oh, okay.
8 seconds.
Yep, be right back.
I would take over, but I can't write on his notepad. It's actually impressive that he can look up there and write down here and get in the right spot.
Okay. Alright, can you guys figure out how the 16 one works? You just basically do the same thing, right? 16, add 16, add 16, add 16. Eventually we should find a number that's on both lists, right? 48 is on both lists. Since it's the lowest number on both lists, you guys done this before? Okay, let's move on then. So, I've done a whole bunch. Why don't you guys try some now? So rather than me doing the work, try it. So you can find the greatest common factor between 90 and 225. And then if you finish that one, 154 and 198. So if you try. If you're stumped, please call me over, right? That's where the feedback comes in. I've given you some knowledge, which truthfully you already had. Now I'm asking you to apply it, and then when you're done applying it, let's get some feedback. Okay?
No, so we need to break it down. Yeah, so you have to do it for 90, you have to also do it for 125, and then figure out what's the top of it. Makes sense? So like they can make a big tree for 90, make a big tree. Right off the bat, if you're doing 90, it's even, you divide by 2, right? And if it's 0, you divide by 10. Make sense? So basically, you need to do factor trees for both of them. Sometimes what I do, I give you guys a head start, and then I'll start doing work on the board. If you're stumped and you need you just need a hand, take a look at the board. If you don't want the surprise ruined for you, then just don't look up. Does that make sense? So I'm just gonna start doing a little bit of work on the board. If you need to take a look, feel free, but you don't have to.
We're actually supposed to write on this?
Yeah, it's for you. The whole point of me printing out notes for you guys, or just having you do that, is I don't want you wasting time doing a whole bunch of handwriting.
I didn't want you in trouble because most of the time it's,
Oh, that's for
take
you.
these, but don't have them.
Ooh, let's go this one. Actually, not okay, but already. 25, we'll go with 9. So if you end up finishing the first one, or if you're absolutely stuck on the first one, I threw something up on the board. Hopefully you can kind of follow what I did. So you might have done something differently than me. Let me show you what I did. I said that 9D was a 9 and a 10. I said a 9 was a 3 and a 3. The 10 was a 5 and a 2, so I rewrote it here as a 2, a couple 3s, and a 5. If you have something different than me, but you still have 2, 3, 3, and 5, that's good. If not, maybe what you need to do then, call me over, I'll come take a look. See if I can find your mistake. 225, I happen to know is 25 by 9. What's that? 225? Okay, so you have something different than me, that's all, right? I did 25 by 9, which is 5 by 5, 3 and 3. Alright. I found out that there's a couple of 3s and a 5 in both. So I said 3 by 3 by 5 is 45. So, if you weren't able to get something similar to that, call me over, I'll come give you a hand. So you have 3, 5, and 5, right? Isn't that what I have? 3, 3, 5, and 5. Right.
in the second half, right here, I have 3, 3, 5, 5. Yeah. So your last step, which you was Tom's. So this one has a 3. This one also has a 3. That one also has a 3. That one has a 5. That one has a 5. So then what's 3 times 3 times 5? 3 is 9. 5. 45. If that's something you can do in your head, that's good. If that's something that like makes more complicated, you need to practice. Because those are the sorts of things where if you constantly go into your cell phone, try to figure out 3 times 3, 5 times, you know what I mean? Then there's a hole, right? You just need to work on it. Oh, multiply them, right? So what's in common then is 3 times 3, which is 9. 9 times 5? Or here, 3 times 3. See how that works?
Wait, what was the
7.
Make sure you get feedback, okay? I mean, we got 2 bodies in the room, right? So even if you're sure you got it, even if you're not sure you got it, ask for help. 299, 33, yeah. Two involved, 11 involved. You may need to steal a chair out of the cafeteria. Yeah.
You just want to What made you put that in the order?
Just whatever came to mind first. So long as you have, so long as your factors for this one were 2, 7, 11, and here it was 2, a couple of 3s, and 11. So if you finish the second one, I don't want to spoil the answer if you're still working on it, but I do have the answer up there, so check yours against mine. If you got it right, that's good, right? Make sure you get feedback, though. Don't just pause. That'll work too. I feel like this was faster. Yeah, because I think it's easier for most kids to break down a factor tree into little pieces. Yeah. What you're doing here, I'm cool with that. If you want to do that, then we'll do it.
It's confusing because like you have to multiply them and find the same.
You do have to do that. Yeah. You know what? So the only reason why I suggest not doing that one or this one here, what if you miss a factor? What if you accidentally forget 11?
Yeah, I did that here.
Right.
I stopped it.
And so it's very plausible when you're doing factors the other way that you might forget one. Whereas this is fairly foolproof because you're taking it all the way down to like the bare elements. So, but if that works for you, yeah, you can take the middle table if you heard it. Doesn't matter to me. We're really tight here. So Michelle. Let me do that right now. Yeah.
What's with the times tables?
Oh, I'm just re-putting together what's in common. So the 2 was on both, the 11 was on both. So then the lowest is 2 times 11. How about we do the next one together as a group just for 1 or 2 of them, and then I'll have you guys do the last one.
Can I snag your attention real quick here? I just want to make sure that we're all on the same page for a few lowest common multiples. Because we're nearly done our notes, right? Yeah, that's our last page. So, why don't I do the first one here, then you guys can try the next two. If you want to try to find a lowest common multiple, we're now looking for a number bigger than these ones. Hello. I guess you. Okay. Daniel. Yeah. Charlene's looking for your props. Okay. Okay. Let's do these last ones here so I can get you guys moved on here. To find multiples, the best way of doing this is just to try to write out the progression. 5 times by 2 is 10, by 3 is 15, then 20, 25, 30, 35, 40. As to how far to write, I don't actually have an answer to that. Sometimes you'll even know the answer. 7, 14, 21, 28, 35, 42. And at some point, you'll find a number that's on both lists. The lowest number on both lists is known as a lowest common multiple. Can everyone listen to this real quick here? I just want to make sure you get this part here. When you find a lowest common multiple, these guys are the factors of the lowest common multiple. That make sense? So when 35 is the lowest common multiple, 5 and 7 are some of its factors. So try the same process on the next two. Truthfully, after that, that's my last slide. So we have about 20 minutes left in class. Here's my suggestion then. I've given you guys something to work off of. I'm not even sure that what we did today is really all that new for many of you. Like, it might be a review. So let me go back to that learning cycle. Here's how you learn. You came to class. You care. You want to be here. We showed you something. Try it. Get feedback. If we don't get a chance to chat with you, call us over, right? Make sure that we have a conversation and make sure this works. Right? So things to work on then. Your assignments, I always recommend do it little by little. Right? So work on the assignment. And we are going to take these journals at some point and take a look over them. So if you haven't done, at the very, very minimum, if you haven't done numbers 9, 61, and 73, I wanted you to do that for warm-up. It's a little late for that now. But try something else then. Right? When I chat with some of you, I can kind of see once in a while that maybe your multiplication facts need a little bit of work. 7 times 9, 6 times 5, right? Those sorts of things where it wouldn't hurt to practice a few of those just to get those skills up to speed. Okay? So got about 20 minutes left. Honestly, work on what you need to work on. I'm not a teacher who's going to like say you have to do this. I want you guys to be in charge of your learning. Does that work? So let me know how the two of us can help.
Oh my gosh.